Alright, I am solving the problems from the book based on what the students have requested. So the first problem is question A from 2.45, and the question asks you to identify whether these two are isomers, and if so, what type of isomers, or whether they are the same molecule. Alright, so we know that when we have isomerism, you can either have constitutional isomerism or we can have stereoisomerism. So constitutional or structural, they are the same, and this is stereoisomerism. And so far in stereoisomerism we have seen cis strands, or which is also the same as geometric isomerism. So this is the same thing. So if it's a stereoisomer, as long as you are in this chapter or up until chapter 4, stereoisomerism is same as what we're going to see as cis strands isomerism or geometric isomerism. So the molecule can be either isomers of each other, or they could be the same molecule. If they are isomers, then you have these two possibilities so far. So based on that, let's see what kind of situation we have between the two structures provided. So the molecule on the left here, if you look at it, this structure here and the structure and the chlorine here and the chlorine here, if you draw a line between these two carbons that contain those two substituents, these two chlorines are on the same side of that line, of this line here. So therefore this is a cis molecule, cis dichloro. In fact, if you want to name this is going to be cis 1 2 3. So 1,3 dichlorocyclohexane, that's going to be the name. So cis hyphen 1 comma 3 dichlorocyclohexane. Whereas if you look at the molecule here and you draw a line, imaginary line like that, then one chlorine is on the bottom of this line and this chlorine is above the line, and therefore this is a trans molecule. Trans, the same name, 1,3 dichlorocyclohexane. So these two are not structural isomers. These two are isomers first of all, right? But they are not structural isomers, they are stereoisomers, because a structural isomer differs in the sequence of bonds we have in the molecule. So for example, if this chlorine was on the 4th carbon, then the sequence of bonds is different from this structure and that structure between these two structures. But here the sequence of bonds are the same: chlorine, carbon, 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 chlorine, chlorine, carbon, 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 chlorine, except the orientation of the two chlorines are on the opposite side. Therefore this is just geometric or cis trans isomerism. Therefore yes, these two are isomeric structures and they are cis trans isomers of each other. Okay, and therefore they are different molecules. That's why they are isomers. So hope that makes sense. Okay, let's take a look at this here. So if you look at the structure here, they have the exact same sequence of bonds as you see here. So carbon, 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 chlorine, carbon, 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 chlorine, and it appears as if, like, this chlorine is pointed upwards and this chlorine is pointed sidewise. This is in the axial position, this is in the equatorial position. But if you just flip this molecule, like push this bond up or this carbon up, push this carbon down and make it flip the chair conformation, you will get a chair conformation in this shape, and the chlorine that is in the equatorial position is now going to go to the axial position, which is same as the structure here. Therefore these two are the same molecule, they are not different. It's just that they underwent a conformational change, and you have one appears one way and the other one appears in a different way. This is chlorine in the axial position, here you have the chlorine in the equatorial position. So these are just the same molecule remaining in different conformations. So same molecule, different conformations. Therefore you can either call this conformers or same molecule with a different conformation. Alright, that is that. So in this problem we have to first identify what the structure is. So let's first draw the the wedge and broken wedge notation. So if you look at this, the chlorine is on the top here and this is a hydrogen on the bottom side. So this is a staggered conformation if you're looking at the molecule from this angle, and you have your chlorine coming to the right and this hydrogen here to the left, and your CH3 is So the right here on the top and the hydrogen here. And if you want to draw this molecule, it is the chlorine and the hydrogens are in the same position. So chlorine, hydrogen, if you are standing in front, and this is the molecule that is closest to you, like that. And now we have a CH3, and you have two hydrogens on the back, carbon, like that. Alright, so this is, if this is carbon 1, this is 1 dichloro 1 2 3 propane. And if this is carbon 1, because that has a closest substituent, this is also 1 dichloro 1 2 3 propane. So this is the same molecule. If you name them, you end up getting the same name for the molecule. So if you notice it, the chlorine on the front carbon and the hydrogen are in the same location on the front carbon, whereas the back carbon seems to have rotated. So if you rotate the front carbon, the back carbon, the CH3 is going to come here. If you rotate it by 120 degrees, it comes here, and this hydrogen is going to go there, and this hydrogen is going to come where the CH3 is. So that's exactly what you have here. So if you just do a 120 degree rotation, you end up getting the structure. Therefore, these two are just conformations of the same molecule. Conformations of the same molecule. They are not different molecules, right? And they are not isomers. They are just same molecule in different conformations. So in this problem, if we draw the wedge and broken wedge notation for the structure here on the left, that's basically what we had in the last problem as well. So you're going to get that here, and then on the back you have here. Whereas the structure here on the right, you're going to see, and of course you're standing here, so that is the front carbon for you. And the structure on the back, it's going to have a Newman projection where you'll have the chlorine here on the top, and you have a CH3 on the right here, a hydrogen here on the left. On the back carbon, you have your chlorine up here, hydrogen comes here, and this hydrogen on that side. So this is going to be 1 dichloro propane, because that is carbon 1, carbon 2, carbon 3. Whereas this is going to be a 1 2 3, right? And of course you have to start numbering from this side. This is going to be a 1 2 3. So 1 comma 2 dichloro propane, and these two are therefore different molecules, and yes, they are isomers of each other, because they have the same molecular formula, but they don't have the same sequence of bonds. The bonds and the linkages themselves are different. Here you have a carbon with two chlorines and then a carbon-carbon. Here you have a carbon next to a carbon, then a chlorine, and then a carbon-chlorine bond. So these two are structural isomers of each other, right? And they are not conformers, or they are not geometric isomers. They are structural isomers of each other. So this is the skeletal structure, and here the skeletal structure is going to be 1,2-dichloro. All right, so that way you can identify that this is not just stereoisomers. Alright, for this problem, if you try to name this structure, one of the easiest way to find out whether the two molecules are the same or different is just to give name it based on systematic nomenclature. So if you want to name this structure, you will start from here. So this is going to be 2-methylpentane, and same thing for this. If you name this compound, you will start from here. So this is going to be 1 2 3 4 5 methyl group on the second carbon, so this is also going to be 2-methylpentane. Therefore these two are the same molecule. same molecule. Now you don't have enough information to comment whether these are conformations of the same molecule because you don't have this projected in the Newman projection. So therefore you don't have to worry about having to say whether these are conformers or not. These are just the same molecule. That's the extent of which you can comment about this. That's pretty much all you need to know about this this kind of questions.